Columnar storage is completely different. We store the data by fields. All fields of the same type, all C1 fields, are chained together. All C2 fields are chained together, 3, 3, 3, 4. Actually, the animation has not been changed. This point on the left side has to go a little bit further down, otherwise the animation is not right. Sorry, I missed that. Why is this so good? You need a little bit of time to think about our commercial applications. We talk about object orientation. In our business, in our products, we have the word objects popping up everywhere. It is the Business Object Explorer. It is the object layer. We have the business process management on top of the business objects. So the word business object is everywhere. That sounds like we are dealing with a single business object at a time, most of the time. This is wrong. We analyzed most of the applications which exist in a typical enterprise system today, and most of the operations we perform in our system are going across multiple instances of one object. An example, we look at all the orders which have to be shipped today. We look at all the orders we have to manufacture in the next 60 days to get the material. We look at all the open items of one customer. We look at all the open items which are due of all customers in order to write a reminder. So most processes in business are going across multiple instances of one or multiple objects. So we are not like the CAD/CAM applications dealing with the drawing of one door of a car, or the door handle, or the hinge of the door. These are objects in the world of cars, and the engineer is dealing with one single object and changing it. In business, we're dealing with many, many, many objects of the same time at the same time, of the same type in the same time. And for this type of operation, this columnar storage has huge advantages. I will tell you a few. First of all, when we store data in this, I call this spaghetti before cooking format. I use spaghetti format, and then last week, a female student told me, no, 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 not spaghetti before cooking, because they are straight in memory and not warped. I said, thank you, that is true. We can compress data from this left table here by a factor 20. Measured several companies, we measured several real data of companies. This is 10 times more the compression which we achieve today in our record-based relational storage. Just keep in mind a factor 10, because more factors are coming. So we store data like this. The typical question is, yeah, how do you get a record back? All these spaghettis, all these strings, have the fields of one field, all fields of one field, but all the fields of record 47 are in the 47th position. So if you want to have a record, if a program asks for, I want to have for record 47 all fields, then we go in the first string to position 47, in the second string to 47, and so on, and reconstruct a row, a record, and give it back to the application. And this is done in-house in the convention center at nearly light speed. You saw the unbelievable relationship between inside the CPU and when we have to leave the CPU, or when we fly to the Mars to get data from disk. Actually, this columnar storage is 15 years old or more. well published, used, many systems are available, but the word was, this is only good for analytics. And actually, it's really good for analytics. And there's not only scientific proof, there's commercial proof. Just look at all the presentations you heard here about Business Explorer within the context of the business warehouse, the speed of the business warehouse accelerator, the Business Explorer on top of T-Rex. This is what we're offering today, and I'm not in sales anymore, but if this doesn't sell, then I don't know what software is selling. This is the best piece of software I have seen the SAP producing the last 10 years. And you see the speed. Every demo, everywhere, we can show the speed on large amount of data. This is what really grabbed me. If we can run through 400 million sales records in 700 milliseconds and produce any spreadsheet you want, ask any query, and I give you the answer in 700 milliseconds. And when I get the new board with 16 cores, I promise it will be under 100 milliseconds. That's a blink of an eye to run through 400 million records. So it has been used for analytics. And 2 years ago, we started and say one of these typical design thinking, or ask ourselves design thinking questions. Why not? Why not using it for transactional systems? And the students' answer is, yes, we can. Yeah, it's a famous president who said this, so I want to make a joke. The relational system, the foundation of our databases, designed or developed, invented by a Mr. Cod in California, working for IBM. He was an IBMer or fellow of IBM. His theory was radical. He said, we don't need a key anymore for data. Data is just data, and it comes in spreadsheet forms. The technical term is we don't need a primary key. Actually, we don't need indices. We just access the table, and with the structure of the table, we exploit the relations and the attributes, and we perform the calculations with the attributes, and we produce a decent answer set. Set was the operative word. And then probably the application has to prettify this a little bit, but that's it. Then a Mr. Date came along. He also worked for IBM and had to put this into a system which is working. And he said, this is not working. We need a primary key. And actually, to achieve speed, we need secondary keys as well. I don't know, but probably the table with most secondary indices will have an SAP 5 secondary indices or 4 secondary indices and a primary key. To maintain these indices, this costs time. This is expensive. The set processing is used only in a limited form in today's system. We could have done more, I admit, but we went for a relatively moderate exploitation of the SQL potential. And we violated Mr. Cod's most important rule, zero redundancy.